Let us discuss some few examples here. Now I have shown you there are two bodies here. Body A is on the table, body B is hanging here. Now the constraint is body A and B are tied with a string, massless, inextensible, with frictionless pulley. Now what will happen? Imagine this body, as I'll draw the picture again so that I can show you the constraint. So imagine this is the system we have taken. The two bodies are there, body A, and this is the pulley system we have. This is body B. So when the system is released due to gravity, body B will be pulled down. Now the body B travels downward and reach here, covering a distance, let us consider as x. The string here will increase like this, whereas here the string is going to decrease and the body A will arrive this position. This is the original position, this is now the new position. Say it has traveled a distance of y. So initially let us consider the length from here to here for the string is L1 and the length of the string from here to here is L2. The total length of the string L is equal to L1 plus L2. Now this side the body goes down by a small distance x. Here the body A travels by y. So what will be the position or the total length of the string now? L is equal to L1 plus x. L1 plus x plus L2. This is L2 minus y. L is nothing but L1 plus L2. L1 plus L2 is equal to L1 plus L2 plus x minus y, or we get x is equal to y. Differentiating x is equal to y means the displacement of B and displacement of A, or distance traveled in this direction and distance traveled in this direction, is same. So since B is moving due to gravity, it is pulling A also. A is constrained to move. Differentiating, we get it dx by dt is equal to dy by dt. That means if the speed of this body is v1, the speed of this body is v2, then we can write v1 is equal to v2. If I consider the acceleration of this body is a1, acceleration of this body is a2, then differentiating this we can also write a1 is equal to a2. So what we are going to get from here, constraint relation, the acceleration of body B and acceleration of body A1 is equal to A2 is equal to A. That means acceleration is same. So since because of gravity body B moves, it is now making body A also to move. Body A is constrained to move the same distance as body moves because body B and body A are tied with the help of a string. Now let us draw free body diagram and simplify the equation. The force acting on B is because of gravity. Let me call this mass as M1. So this will be M1G. Tension in the string T. For the pulley, tension will act in this direction. Same string, tension will act in this direction. For body A, tension will act in this direction. This mass is, let us consider as M2. Then this side the force will be M2G. Upward force will be due to the ground, normal reaction N. For body of mass M2. We can write the equation M2 for body of mass M1 I'll take. This is M1G minus T is equal to M1A. And for body of mass M2, only one tension is there towards horizontal direction, that is M2 into A. Acceleration is same for both the bodies. So we can write this as M1G is equal to M1 plus M2 into A. Simply we can get the value of acceleration as M1G divided by M1 plus M2. Substituting this value of A in the second equation, we can easily get the value of tension. T will be equal to M1 M2G divided by M1 plus M2. So did you follow this? The body B is traveling a distance x downward. A travels towards right the same distance. Therefore, the acceleration of both the bodies is same. A1 is equal to A2. So by making free body diagram, M1G minus T is M1A, T minus M, T is equal to only M2A. We can get the value of acceleration and tension. Let us see another example. This time we have two bodies are hanging down with the help of a fixed frictionless massless pulley. Let me call this mass as M1, this mass as M2, correct? So let us see the constraint. This is fixed position. This is a pulley. So we will locate the position of mass M1, position of mass M2. So let us consider this is M1. This body is of mass M2. Let me call this length as L1, this length as L2. So what you are going to get? L is equal to L1 plus L2. Now we will, because of gravity, let us say this comes down by X. Imagine this moves up by Y. Now the position M1 is at this position, M2 a body is at this position. So what will be the length total now? Now this will be from here to here as L1 plus X. Total length becomes L1 plus X plus this will become L2 from here to here as L2 minus Y. L2 minus Y. So L is L1 plus L2. So what are you going to get? We cancel out L1, L2. We get X is equal to Y. Double differentiating. If this velocity is V1, this velocity is V2, we can write V1 is equal to V2. One more differentiating. If this acceleration is A1, this acceleration is A2, we can write A1 is equal to A2. That is equal to A. This is velocity is V. So constraint relation has proved here again that both the bodies will travel with the same acceleration. This will come down with acceleration A. This will move up with acceleration A. Now let us make free body diagram. This body due to gravity is pulled down M1G, tension upward T. For this pulley, tension will be in this direction. Same mass frictionless spring, tension here, tension in this case T here. This will be M2G. So for body of mass M1, write the equation, free body diagram equation. Positive axis will be in the direction of acceleration M1G. So we have M1G minus T is equal to M1A. For body of mass M2, work out the positive direction will be the direction of acceleration. T minus M2G is equal to M2A. This is for mass M2. Simplify, what we are going to get? M1 minus M2G is equal to M1 plus M2 into A. Simply we can get acceleration as M1 minus M2G divided by M1 plus M2. Substituting this in either equation 1 or 2, we can simply write T is equal to M2 into this value M1 minus M2G divided by M1 plus M2 plus of M2G. Expanding the term and cancelling it out, we get 2 M1 M2G divided by M1 plus M2. So this getting tension and acceleration are very easy. First, once we get the acceleration constraint, due to the constraint, we can easily work it out. So the steps what we are going to follow here. The first step is always use the constraint relation, calculate or find the relation of acceleration. Relation of acceleration. Second, make free body diagram. Third, generate the equations and solve it. So first you have to take constraint relation. As we have said, there are 2 or 3 methods of constraint. The easier one I have shown, where the length of the strings are going to change. Get the relation of acceleration between the bodies which are moving. Let us see some more examples so that it will be more clearer to you while we solve the problems. Now in this example, we have 2 bodies of mass M1 and M2, and these 2 bodies, how they are going to move, just you have to first notice this. Thereafter we will discuss the problem. So we have mass M1, mass M2, or you can say this is a heavier mass, then this is lighter mass. When we start the animation, you can just check how the 2 bodies are moving. This body is coming down, this body is moving up. Notice some more points while you look at the picture again. I want that you should notice this picture very carefully, what is happening. Did you notice anything? Let us start again. Now here the mass from the ground is only this distance. When this mass M1 travels this distance, mass M2 travels a bigger distance or larger distance. Right? The string is rolling over. This is the same string which is existing here. But this travels a lesser distance. This travels a larger distance. See very carefully. See, when this body has traveled this much, it's already has reached to this point. Now this will reach to the topmost point when this travels down. What does it indicate? The acceleration of this body of mass m2 should be larger as compared to this body. Correct? So m1 coming down, m2 moving up. So this body has lesser acceleration, this body has greater acceleration. Let us see the problem again. Fine. We will draw this picture again and draw the constraints for this particular body. So this is the movable pulley. Here we have a fixed pulley, this pulley which is called fixed to the rigid support. Then here we have mass m1 attached. Here we have mass m2 is attached. Correct? This string length L1 up to this. This string, this part of the string length L2. This part of the string length L3. This is the same string. Correct? This is another string. Another string we have. Correct? So imagine this m1 travels a distance x down. X, as we have seen in this case. So this pulley which is movable, the center of pulley, let us call point P, will now arrive at this position. This P dash. The P dash distance also must be equal to x, because this is inextensible string. So when this body goes down by x, now this body is over here, this pulley also should follow. So this will travel a distance x down. Now the string will roll over this pulley like. This string which we have considered will now roll over this pulley and will now start going through like this. Like this. So this side it will go down x, this side will go down x. This mass will go up like this. It will travel a distance of y. Correct? So this side the string will be going down x, this side also going down because pulley has gone down here. So what is the constraint you have? Initially the total length will be equal to L1 plus L2 plus L3. Now L is equal to, this is L1 minus y. L1 minus y plus L2, this length from here to here it was L2. Now L2 plus x. Very good. Now tell me about L3. L3 was from here to here. Now the pulley system is up to this. So L3 plus x. Substitute L is equal to L1 plus L2 plus L3. What we get it from here? Minus y plus x plus x. Y is equal to 2x. Suppose this body is coming down with acceleration a1. This body is moving up with acceleration a2. Double differentiated, this will be a2 is equal to 2 times of a1. So let us assume, let a1 is equal to a. What will be a2 equal to? 2a. Means if this acceleration a1 is a, this a2 will be 2a. So that is what we concluded. This body is coming slowly down, this body is accelerating faster. So therefore this body has to cover more distance. So its acceleration will be greater. This is 2 times of a. Whereas this body travels from here to here. This is lesser acceleration. This is a. Correct? So now with the constraint relation has given us that this body is accelerating with 2a. This body is accelerating downward with a. I will draw the free body diagram. Let us check this picture again. See, this is the position. This is coming down. This is moving faster. Correct? So this is coming down with acceleration a. This is moving up with 2a. Now we generated constraint equations. Let us draw free body diagram. So what are the forces? So this mass I will take it as m1. So on this body it is m1g. Tension in the string here 2t, because this tension is t. Okay. Here we have the force. This is m2g downward. This side tension t. This tension t. This tension t. So we can write for body of mass m1. m1g in the downward direction. m1g minus 2t is equal to m1a. For body of mass m2, we can write t minus m2g is equal to m2 into 2a, because the acceleration of this mass m2 is twice the acceleration of this body. Now let us simplify this. First we multiply this equation with 2 so that we can cancel out this equation. 2t minus 2m2g is equal to 4m2a. Now we'll bring the equation number 1 here. We get it m1g minus 2t is equal to m1a. So what we are going to get? A is equal to m1 minus 2m2g divided by m1 plus 4m2. Substituting this value of A in either equation 1 or 2, we can easily get our tension. So did you follow what we have done here? We have first step we have taken and calculated constraint, that is relation of acceleration. Second step we made free body diagram. Third step we have wrote the equation and solved. Correct? So acceleration we got, m1 is coming down with A, m2 is moving up with 2a, as I have indicated or explained in this particular figure. Similarly, I'll give you one more example. This time you need to try how the two bodies are going to move. Okay, let us go for the fourth example. Now here we have this mass one, this mass another, but this mass is resting on the horizontal surface. Let us call this mass as m2. This mass here is m1. So m2 is due to gravity, it will pull down, and m1 will be moving in this direction. So let us look into this picture and see how the two bodies are moving. So first let us analyze it. So see how the two bodies are going to move. First let us see in every direction how this picture looks like. Observe the complete mechanism. This body has moved down. Followed? Here we have taken mass m1 has going down. So there will be tension here, tension at this point, tension at this point. Here there will be 2t tension. Okay, so let us see how the two bodies are moving. So this body now has traveled from here. Earlier it was at this position. Now it has traveled in this direction. Pulley which was here has traveled to this position, and the mass which was here has traveled to this position. This mass is mass m2. So the string which is there, it will roll over the pulley here, and it's rolling over the pulley like this. Correct? So this tension is. So let me draw this figure again and draw the constraint. This mass I will take it as m1. This is a fixed pulley. Now here we have another movable pulley. This string is fixed here. Now from here we have another body of mass m2. Correct? So what will happen? Due to gravity, this body is going to move down. It will pull the pulley forward, and as it is connected at the center of the pulley, this mass will move up. So first let me take the length of the string from here till here as L1. From this position to this position as L2, and this part of the string from here till here as L3. So what will be the total length? L is equal to L1 plus L2 plus L3. This mass goes down. Now M1 is here. Let me call it travels a distance of x. The string will be like this. Because of this, this pulley system will move. This movable pulley will move forward. Let us say it has traveled a distance of y. Now the string will roll over from here, and this part of the point P has gone to P dash. So this string will start from here. Therefore this body will move forward same distance y. So due to constraint, what will be now the total length? L1, this is L1 plus x, plus L2, this length is from here to here as L2 minus y, plus L3, this length is from here to here L3 minus y. Very good. So what you are going to get from here? X is equal to 2y. X is the displacement of M1. Y is the displacement of pulley and also of M2. So if I consider this acceleration as A2, this acceleration as A1, double differentiating, A1 will be equal to 2A2. Let A1 is equal to A. A2 will be equal to A by 2. So when this comes down with acceleration A, this will move forward with acceleration A by 2. Now let us make the free body diagram. For the first body in the downward direction, it will be M1G. For second body, this side normal reaction N. This is M2G. This side tension 2T. This tension T. So for M1, get me the equation. M1G downward minus T. What is its acceleration? M1A, equation number 1. For body of mass M2, 2T in the horizontal direction is equal to M2 into A by 2, equation number 2. Let us solve these two equations. Second equation multiplying by 2. 4T is equal to M2A. First equation multiplying by 4. M1G 4 times minus 4T is equal to 4M1A. What we are going to get acceleration? A is equal to 4M1G divided by M2 plus 4M1. Equating the value in equation number 2, we can rewrite the tension T is equal to M1 M2 G by 4M1 plus M2. Body of mass M1 when comes down with acceleration A, we have considered this body starts moving in this direction with acceleration A by 2 because it is attached to the pulley. That pulley rolls over. This spring is inextensible. So when it comes down by X, this travels by Y. And remember, Y is nothing but X by 2. Now, another example, we will take it up. This example, you need to analyze and make the constraint first, then make free body diagram. Let us go into the next example. Now, here we have two bodies. So, very simple picture we have. This is a fixed pulley. This is a fixed pulley you have. This is the rigid support. You have movable pulley. This pulley attached to the center. So, as the two bodies M1, M2 are there, one moves. The second is constrained to move. Let us look into first the moving picture. See, this body is traveling down. Pulley is also traveling down. This body is moving up. What did you notice? This mass has traveled greater distance. See how much distance it has traveled. If we call this as X, pulley has traveled down by only Y. Even this mass has traveled a distance Y. If you take a scale and measure, let us look into the picture again. Fine. So this mass M1 is coming down, M2 is moving up. So just look into how much distance these two bodies travel. See the distance traveled by this mass. If you take a scale and measure, suppose it is X for this mass. Pulley has come down by Y. Okay, it has traveled down by Y. Whereas this body also has traveled by Y. If you take a scale and measure, this is coming down, pulley system is coming down by Y. Since with this string, this body is attached, this body lifts up by Y. But whereas this mass M1 has rolled down to this particular position, traveling a distance of X. So let us now draw the free body diagram and work it out. Let me make the constraint equation first. So I will take this as the fixed pulley. This is the body of mass M2. This is mass M1. This end is fixed. So now this M1 moves down by X. When it travels a distance X. This pulley, center of the pulley, point P, now will be positioned here. This point is P dash. Let us take it as traveled a distance of Y. This mass will be now positioned here. mass is m2, it will also travel a distance of y. Just now we have seen this picture, and the string will now roll over like this. So let me take this length of the string as L1, this length of the string as L2. So total length will be L is equal to L1 plus L2. Now what happens? L is equal to this length from here till here is L1. It has come down by y, gone excess by x. So it is L1 plus x. This is L1 plus x minus y. Did you follow this point? L1 plus x minus y. Whereas this is L2 minus y plus L2 minus y. What do you get? X is equal to 2y. Differentiating, if I consider this acceleration as a1, this acceleration as a2, then a1 is equal to 2a2. Let a1 is equal to a, a2 will be equal to a by 2. So if this comes down with acceleration a, this goes up with a by 2. Correct? Now make a free body diagram for mass m1. What are the forces acting on this body? On this body, one force is m1g. This side tension T. This is 2T. This is 2T. This side you have m2g. This is coming down with acceleration a. This is going up with acceleration a by 2. m1g minus T is equal to m1a. For second body, 2T minus m2g is equal to m2 into a by 2. This is our equation 1. This for equation 2. This for body of mass m2. First constraint we already made. So we get the equation like this. Simplifying. This second equation will become now 4T minus 2 m2g is equal to m2 into a. Multiply the first equation with 4. 4 m1g minus 4T is equal to 4 m1a. Simplifying. A is equal to 4 m1 minus 2 m2 divided by 4 m1 plus m2 into g. Substituting this value in either equation 1 or 2, we can get the tension in the string. Let us analyze another example.